You ever feel like you're talking to an AI with the memory of a goldfish? Explaining the same thing over and over again? Well, today, we're diving into a system that's designed to fix that for good. It's an AI memory that's modeled directly on the human brain.
Right? It's a frustration we've all been through. You have this amazing, detailed conversation. You set up all the context, and then, poof, the very next prompt, it's like it never happened. And that's because most AIs today are what we call stateless. They have no real memory of the past beyond a tiny little window. They basically only live in the now, which is why they feel more like a simple calculator than a real thinking partner.
And this slide really lays out the core of the problem. On one side, you've got the AI's memory. It's brittle, it's stateless. On the other side, you've got our memory. It's dynamic, it's alive. It doesn't just store facts, it learns, it connects ideas that seem totally unrelated, and, this is super important, it knows what to forget. It gets rid of the junk. The whole goal here is to bridge that massive gap.
So how in the world do you build a better memory for an AI? Well, you don't have to reinvent the wheel. You just look at the most incredible memory system ever designed, our own brain. And that's the whole idea behind smart memory. It's built on a cognitive blueprint that actually mimics how our own minds work.
This is really the foundation of the whole thing. Instead of just one giant, clunky database, Smart Memory uses a system of 5 different specialized memory types, and each one has a very specific job to do, just like the different memory systems we have buzzing around in our own heads. Let's break them down.
First up, you've got Semantic Memory. The easiest way to think about this is as the AI's book smarts. This is where all the timeless, context-free facts are stored. Things like the sky is blue or Python is a programming language. It's the AI's fundamental library of how the world works.
Then we have Episodic Memory, which is basically the AI's life story. This is where it keeps a diary of its personal experiences and events, along with all the juicy context. It's not just about what happened, but when it happened and why. This is the key to an AI actually remembering your conversations and building on them over time.
And then there's Procedural Memory. Think of this as the AI's muscle memory. This is where it stores actual skills and step-by-step instructions. It's not about knowing that something is true, it's about knowing how to do something. This is what turns an AI from just a know-it-all into a can-do-it-all agent. Okay, so storing information is one thing. That's great. But what makes this whole system so powerful is that the memory isn't just sitting there. It's not static. It's alive. It's constantly working in the background, learning, evolving, and actually getting smarter on its own.
And it does this using a set of clever background processes called evolution algorithms. Now, these are all inspired by real cognitive science, and their whole job is to actively organize, strengthen, and even prune the AI's memories. This is where the real intelligence starts to emerge. So how does an AI make a memory stronger? It actually uses a technique you might remember from school, based on something called the spacing effect. Just like when you're studying for a big exam, pulling up a memory at just the right intervals, after an hour, then a day, then 3 days, makes that memory stick. It becomes much, much harder to forget.
But, getting smarter also means knowing what to forget. And the system manages this using something called interference theory. So like you see on the left, if 2 memories are competing with each other, say 2 different ways to tackle the same coding problem, the system might weaken them a bit. But on the right, when 2 memories actually support each other, their connection gets stronger. This helps the AI build a knowledge base that's coherent and not full of contradictions.
And that leads us to the final piece of this evolution puzzle, strategic pruning. Seriously, think of it like a gardener for the AI's brain. The system is constantly checking memories for quality, seeing if they're redundant or just plain old. Then it gives them a value score and strategically removes the clutter. This keeps the memory sharp, relevant, and super efficient.
So we have all these different memory types, and they're all constantly evolving. But how do they all connect? How does the system go from just having a bunch of isolated facts to creating a real web of understanding?
Well, the secret sauce is a special memory type called Zettelkasten. It's a German word that means slip box. And it's a way of managing knowledge by creating these small, atomic notes about a single idea. So here, for example, we're adding one little fact about attention mechanisms. But the real magic is what happens the second you save that note.
The moment that little note is added, the system just springs to life. It automatically pulls out the key concepts, it goes searching for any other notes that are related, and then it instantly weaves this new piece of info into a bigger knowledge graph by creating links in both directions. And the best part? This all happens automatically. No manual work needed.
What you end up with is this incredible, dynamic web of knowledge. It's not just a flat list of facts anymore. It's a network where ideas are interconnected in meaningful ways. This lets the AI and you surf through concepts, discovering relationships, and insights that you never would have seen otherwise.
Okay, this is all very cool tech. We've got a cognitive architecture, evolving memories, a knowledge web, but what does this actually mean in the real world? Why is this a total game changer for AI agents?
This table really sums it all up. We're moving away from the old world of manual connections and static data and into a new world of automatic linking and constant evolution. A traditional database is passive. It just sits there. But smart memory is an active participant in its own learning. It's constantly getting better all on its own.
And the result of all this? We finally get AI partners that are truly context-aware and can give us personalized interactions. Because the memory is grounded in facts, it massively reduces those annoying AI hallucinations. And it's built from the ground up to plug right into the tools that developers are already using, like LangChain and AutoGen.
So I'll just leave you with this question. Forget everything you know about the limitations of today's AI. What could you build? What problems could you solve? If you had an AI that didn't just spit back information, but one that truly understands, connects, and most importantly, remembers, the possibilities are just getting started.